everyone, I am Jirin.
And I am Ella.
And this is
Stematics 101.
So for our very first episode, we're going to tackle about the simple or basic nature of derivatives in calculus, as well as on how to solve simple problems about it.
So without further ado,
Let's dive right in!
As mathematics becomes complex over time, with new aspects arising eventually, we then get introduced to calculus, a branch of mathematics that focuses on continuous change. Studying this field deeply, we will somehow observe that the calculus has its own essence. This essence, truly significant by itself, is no other than called the derivatives.
because of this, what does a derivative means? As introduced by Isaac Newton around 1665 and later developed by Gottfried Wilhelm Leibniz, a derivative refers to the instantaneous rate of change of a function with respect to one of its variables. This rate of change is a comparison of the change in one quantity to the continuous change in a second quantity.
For better understanding, derivatives are somehow comparable to some occasions. For instance, the amount of money your employer owes you compared to the length of time you worked for him determines your rate of pay. Another one is that the quantity of the displacement of a moving object with respect to time determines an object velocity.
Geometrically speaking, the derivative is the slope of a curve at a point on the curve. Further studying calculus, you will become aware that the process of finding that derivative is called differentiation. As we all know, slope is equals to rise over run in a graph of a constant. However, since we are using a curve, various change in the rise and run will be given. Thus, the formula will become delta y in respect of delta x, or change in y over change in x.
From this formula, it is noticeable that the given slope is coming linearly from a curve. Hence, we have to find the definition of derivatives using the limit of the slope of a tangent line at a given point. Commonly, the equation used to solve the said matter in this: limit of f of x plus delta x minus the f of x over delta x as delta x approaches to 0. To prove that this slope is truly a function, delta y is respect of delta x could sometimes be called as f prime of x.
So in totality, the derivative of f of x with respect to x is the function f prime of x and is defined as the f prime of x is equals to the limit of f of x plus delta x minus the f of x over delta x as delta x approaches to 0. Finding the indicated derivative may be long, but we assure you this will be indeed easy. To prove, we have two sample problems here. The first one being f of x is equals to 4 times x squared minus 1. And the second one being f of x is equals to negative 7x raised to negative 3.
Problem, we have here find the indicated derivative of f of x is equals to the 4 times x squared minus 1. The given problem wants us to find the required derivative for the said equation. For the first thing that we want to do right away is to write the formula, which is the f prime of x is equals to the limit of f of x plus delta x minus the f of x over delta x as delta x approaches to 0. Now that we have our formula already provided, the next thing to do is to substitute the equation into the formula. The f of x plus delta x will be substituted to the x of 4 times x squared minus 1 and then 4 times x squared minus 1 will be substituted to this f of x. Now, we have here the f prime of x is equals to the limit of 4 times x plus delta x squared minus 1 minus 4 times x squared minus 1 over delta x as delta x approaches to 0. After this, we will solve for the whole quantity of the numerator starting by solving for the x plus delta x squared using the abridged multiplication. Now, we have here the f prime of x is equals to the limit of 4 times x squared plus 2x delta x plus delta x squared minus 1 minus 4 times x squared minus 1 over delta x as delta x approaches to 0. Next, we will distribute terms that requires distribution. We will distribute the 4 to x squared plus 2x delta x plus delta x squared minus 1. Well, then this negative 4 will be distributed to x squared minus 1. Now, we have here the f prime of x is equals to the limit of 4x squared plus 8x delta x plus 4 delta x squared minus 4 minus 4x squared plus 4 over delta x as delta x approaches to 0. After this, we will combine like terms. In this equation, 4x squared and negative 4x squared are alike. But since they subtracted to each other, they will be cancelled. The same thing goes to negative 4 and 4. Since they subtract to each other, they will also be cancelled. Now, we have here the f prime of x is equals to the limit of 8x delta x plus 4 delta x squared over delta x as delta x approaches to 0. Taking consideration of the denominator now, we will divide the numerator to the delta x now. The delta x of 8x delta x will be cancelled since this and the denominator will take up as 1, while the delta x of 4 delta x squared will have its exponent subtracted to the exponent of delta x in the denominator, which is 1 as stated. By the quotient rule in the operation with powers. Now, we have here the f prime of x is equals to the limit of 8x plus 4 delta x as delta x approaches to 0. Taking consideration of limits now, it is stated that delta x approaches to 0, meaning all delta x left within the equation will be substituted to 0. In this case, 0 will substitute the delta x of 4 delta x, resulting for this whole term to be cancelled. Now, we have only 8x as the answer. Meaning, the indicated derivative of the sample problem, f of x is equals to 4 times x squared minus 1. In totality, results to the f prime of x is equals to 8x. As you can see, solving for the indicated derivative seems to be long, but it is truly easy. Using the formula, f prime of x is equals to the limit of f of x plus delta x minus the f of x over delta x as delta x approaches to 0. We can simply find the derivation of any given equations. Like the answer 8x, we could still obtain more derivations from this.
For the second problem, we have here, find the indicated derivative of f of x is equals to negative 7x raised to negative 3. The given problem wants us to find the required derivative for the said equation. Before finding the indicated derivative, we must first keep in mind that the given equation has a negative exponent. In the principles of widening of the power notion, a power of some number with a negative exponent is defined as unit divided by the power of the same number with the exponent equal to an absolute value of the negative exponent. Meaning, our negative 7x raised to negative 3 can as well be written as negative 7 over x cubed. After this, the first thing we want to do right away is to write the formula, which is the f prime of x is equals to the limit of f of x plus delta x minus the f of x over delta x as delta x approaches to 0. Now that we have our formula already provided, the next thing to do is to substitute the equation into the formula. The f of x plus delta x will be substituted to the x of negative 7 over x cubed, and then negative 7 over x cubed will be substituted to this f of x. Now, we have here the f prime of x is equals to the limit of negative 7 over x plus delta x cubed plus, since these signs are both negative, 7 over x cubed as delta x approaches to 0. After this, we will solve for the whole quantity of the numerator starting by solving for the x plus delta x cubed of this term using the abridged multiplication. Now, we have here the f prime of x is equals to the limit of negative 7 over x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed plus 7 over x cubed over delta x as delta x approaches to 0. Next, we will add the two terms. We will do this by first seeking the least common multiple of the denominators, which is now x cubed times x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Now, we will convert the two polynomial fractions to their common denominator. Now, we have here the f prime of x is equals to the limit of negative 7 times x cubed plus 7 times x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed over x cubed times cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed over delta x as delta x approaches to 0. Next, we will distribute terms that requires distribution. Negative 7 will be distributed to x cubed, simply obtaining negative 7x cubed. 7 on the second term will be distributed to x cubed plus 3x squared plus 3x delta x squared plus delta x cubed, while x cubed in the denominator will be distributed to x cubed plus 3x squared plus 3x delta x squared plus delta x cubed. Now we have here the f prime of x is equals to the limit of negative 7x cubed plus 7x cubed plus 21x squared delta x plus 21x delta squared plus 7 delta x cubed over x raised to 6th power plus 3x raised to 5th power delta x plus 3x raised to the 4th power delta x squared plus x cubed delta x cubed over delta x as delta x approaches to 0. After this, we will combine like terms. In this equation, negative 7x cubed and positive 7x cubed are alike. But since they subtract to each other, they will be cancelled. And now we have here the f prime of x is equals to the limit of 21x squared delta x plus 21x delta x squared plus 7 delta x cubed over x raised to 6th power plus 3x raised to 5th power delta x plus 3x raised to 4th power delta x squared plus x cubed delta x cubed over delta x as delta x approaches to 0. Taking consideration of the denominator now, we will divide the numerator to the delta x now. After cross-multiplying the delta x to the denominator of the whole numerator, the delta x of 21x squared delta x will be cancelled since this and the denominator will take up as 1. The delta x of 21x delta x squared will have its exponent subtracted to the exponent of delta x in the denominator, which is 1, as stated by the quotient rule in the operation with powers, and the same thing applies to 7 delta x cubed. Now we have here the f prime of x is equals to the limit of 21x squared plus 21x delta x plus 7 delta x squared over x raised to 6th power plus 3x raised to 5th power delta x plus 3x raised to 4th power delta x squared plus x cubed delta x cubed as delta x approaches to 0. Taking consideration of the limits now, it is stated that delta x approaches to 0, meaning all delta x left within the equation will be substituted to 0. In this case, 0 will substitute the delta x of 21x delta x, 7 delta x squared, 3x raised to 5th power delta x, 3x raised to the 4th power delta x squared, and x cubed delta x cubed, resulting for these terms to be cancelled. Now we have only 21x squared over x raised to the 6th power. Simplifying this, we can obtain 21 over x raised to 4th power. Meaning, the indicated derivative of the sample problem f of x is equals to negative 7x raised to negative 3 in totality results to the f prime of x is equals to 21 over x raised to the 4th power. Again, solving for the indicated derivative seems to be long, but it is truly easy. Using the formula f prime of x is equals to the limit of f of x plus delta x minus the f of x over delta x as delta x approaches to 0, we can simplify the derivation of any given equations. Like the answer 21 over x raised to the 4th power, we could still obtain more derivations from this.
Solving for derivatives is very time-consuming, right, Ella?
You are right, Jeril. It is easy and very important. How do I say so?
Now you may wonder why defining derivatives is our very first episode in the Stematics 101.
So as you can see, as STEM-loving people, we tend to solve problems quantitatively. So in able to solve some of these problems, we can apply simple derivations to its equation to obtain some answers.
For instance, in physics, physicists could apply derivatives to calculate the velocity of an object at any instant. The same thing Isaac Newton had done to know how fast the apple was traveling just before the impact to his head.
So in business mathematics, investors could apply derivatives to calculate market growth rates or the changes of stock values in accordance to time.
And in aeronautics, aeronautical engineers could apply derivatives to calculate the speed of a satellite or the rate of its positions with respect to time within the atmosphere. And the list goes on and on. Derivatives are applicable to other STEM fields such as chemistry, biology, economics, engineering, and more.
So in next time you think derivatives is time-consuming and very hard, think of it this way. So seeking for derivatives is essential for our day-to-day basis, especially for us STEM people as we encounter numbers. Lots and lots of numbers.
We hope you learn a lot in this video. Try to check comprehension.
Thanks for watching, guys!
Also, you can comment down below the topics like law of motion or the shortcut method of derivation.
Also, don't forget to like, share, and subscribe for it will help us a lot and to update you for more future tutorials.
Again, I am Jiril.
And I am Ella, and this is Stematics 101. Bye!
Bye!